The universe is hiding its strangest secrets in plain sight. We are about to journey through 25 of the most bizarre cosmic events ever recorded, a collection of genuine astronomical oddities that defy simple explanation and stretch our understanding of reality itself. By the end, you will witness phenomena so peculiar they make science fiction seem tame. We will encounter a star that refuses to die, a galaxy missing its ghostly glue, and a signal from the void that screamed for just 72 seconds before vanishing forever. What single cosmic mystery do you find the most compelling? Our first stop is a moment frozen in time, a single line of code printed on a continuous sheet of paper that sparked one of the greatest cosmic mysteries of the 20th century. It was August 15, 1977, at the Ohio State University's Big Ear radio telescope. This giant instrument was silently listening to the sky, sweeping its focus across the cosmos like a slow, patient ear. Suddenly, it heard something. For exactly 72 seconds, a narrowband radio signal, 30 times more powerful than the background noise of deep space, blared into the receiver. It came from the direction of the constellation Sagittarius. The signal was so startling, so perfectly aligned with what scientists predicted an artificial transmission from the stars might look like, that astronomer Jerry Amon circled the alphanumeric sequence on the printout and wrote one word beside it in red pen: "Wow." That sequence was 6EQUJ5, a coded representation of the signal's incredible intensity. And then, just as suddenly as it arrived, it vanished. Decades of follow-up observations using far more sensitive equipment have pointed at that same patch of sky and heard nothing but silence. The wow signal was a one-time scream into the void. Explanations have ranged from a passing comet to a secret military transmission, but none fit the data perfectly. It remains the purest, most tantalizing maybe in the search for cosmic company, a 72-second question mark that has never been answered. That fleeting signal was a whisper from the dark, but sometimes the universe hides its strangest clues in plain sight, right in front of our eyes. For years, a star called KIC 8462852, or Tabby's star, was just another flicker in a sea of data from the Kepler Space Telescope. Kepler's job was to find planets by watching for the tiny, regular dips in starlight that occur when an orbiting world passes in front of its sun. But this star was different. Its light didn't dip in a gentle, predictable rhythm. It plunged. Astronomers and later citizen scientists with the Planet Hunters project saw drops in brightness so severe and so chaotic they defied all logic. The star's light would fade by a staggering 22%, stay dim for days, then snap back to normal. Other times, it would flicker erratically like a candle in a draft. No planet, not even a Jupiter-sized giant, could block that much light. The only natural object that could would be something enormous and uneven passing in front of the star. The most tantalizing and sensational explanation quickly captured the public imagination. Could it be an alien megastructure? The idea was based on a concept by physicist Freeman Dyson, who theorized that a supremely advanced civilization might build a vast swarm of energy collecting panels around its star, a Dyson sphere. Such a partially completed, messy swarm could perfectly explain the bizarre, jagged dimming patterns. It was a hypothesis born of sheer desperation because every conventional explanation fell short. A swarm of comets, it would require an implausible number of them, all on wildly different orbits. A recent planetary collision, the dust should have cleared or spread out by now. A dusty, misshapen debris disk, possibly, but the star isn't young enough to have the typical thick disk of a stellar nursery. Years of intense study have leaned toward more natural, if still spectacular, causes. The leading theory now suggests a massive, uneven cloud of dust and debris, perhaps from the slow breakup of a moon or a pulverized planet, is orbiting the star in a long, eccentric loop. This dust is fine, not solid, which is why our telescopes see no clear blockage in infrared light. But the exact nature of this cosmic wreckage remains unknown. Tabby's star stands as a monument to mystery, a reminder that sometimes the most profound discoveries begin not with a eureka, but with a simple, puzzled question from a volunteer staring at a light curve on a home computer. It taught us that the line between science fiction and science is often just a strange twinkle in the data. Tabby's star taught us that even the familiar act of a star dimming can hide profound strangeness. But what about a star that doesn't just flicker, but paints the cosmos with impossible geometry? Far from the chaotic dips of Tabby's star, there exists a structure of breathtaking, almost artificial precision. In the constellation Monoceros, the unicorn, the Hubble Space Telescope captured an image that defied all expectations of celestial beauty. It is called the Red Rectangle Nebula, and it looks exactly as its name suggests. At its heart lies a pair of aging stars locked in a tight dance. As these stars shed their outer layers in the final stages of their lives, they do not create a typical billowing cloud. Instead, they have sculpted something astonishing, a vast, glowing X-shape with its sides connected by rungs of luminous gas, forming what appears to be a hollow, three-dimensional rectangle of deep red light. This is not an artist's rendering, it is a real photograph. The leading theory suggests that the dense disk of dust surrounding the binary stars funnels their expelled material into two opposing cones, like twin searchlights shining into space. From our vantage point, looking nearly edge-on at this cosmic hourglass, we see the outlines of those cones as the iconic X. But the perfection of that symmetry is the real puzzle. Why is it so precise? What physical processes keep those outflows so balanced and sharp over such vast distances? Even more intriguing is what that red glow represents. The nebula's crimson color comes from a type of emission known as extended red emission, linked to complex organic molecules called polycyclic aromatic hydrocarbons. In simpler terms, this geometrically perfect structure in the void is filled with the very chemical building blocks of life. It is a cosmic art gallery and a chemical factory combined, a place where the end of stars creates both stunning order and the raw ingredients for beginnings. This nebula forces us to wonder, is such perfect structure a rare accident or a hidden signature of how some stars choose to die? The red rectangle shows a star's death can be a work of geometric art. Yet in the constellation Sagittarius, another stellar duo is engaged in a relationship of pure cosmic violence. This is PSRB 1957+20, known more evocatively as the Black Widow pulsar. It is a millisecond pulsar, the rapidly spinning corpse of a massive star that exploded. This neutron star is so dense a single teaspoon of its material would weigh as much as a mountain, and it spins over 600 times every single second, sweeping the universe with a lighthouse beam of radiation. Its crime is what it is doing to its partner, a small, cool brown dwarf star locked in a horrifyingly close orbit. The two are separated by a distance roughly twice that between the Earth and our Moon, completing an orbit in just over 9 hours. At this intimate range, the pulsar's furious energy is a perpetual death sentence for its companion. It bombards one face of the brown dwarf with intense radiation and a hurricane of high-energy particles, a stellar wind of unimaginable ferocity. This constant blast is literally cooking and vaporizing the smaller star, stripping its material away atom by atom and blowing it out into space. The result is a breathtaking and terrifying sight, a vast glowing tail of ionized gas that streams behind the doomed brown dwarf, making it look like a comet being evaporated by a cosmic sun. This is stellar cannibalism in its most direct form. The pulsar, having already died in a supernova, now feeds on the very essence of its living partner to spin itself ever faster. Astronomers see this as a key to understanding a dark chapter in binary star evolution, revealing how one stellar corpse can consume its neighbor to become a hyper-fast cosmic zombie. The Black Widow is a reminder that in the deep reaches of space, some partnerships are not about mutual dance, but about slow, inescapable annihilation. That pulsar's deadly feast reveals a universe of violent relationships. But what if our entire galaxy, along with every star you see at night, is caught in a far larger and more mysterious embrace? We are not floating freely in space. Our Milky Way, along with our entire local group of galaxies, is falling. We are streaming through the cosmos at an astonishing speed of over 600 kilometers every second, pulled by a force we cannot see. The destination of this universal river is a place astronomers call the Great Attractor. It is not a black hole or a bright quasar, but a vast, diffuse region of gravitational excess, a heavyweight in the cosmic tug-of-war, located about 250 million light-years away in the direction of the constellations Centaurus and Norma. For decades, this was a profound puzzle because when we looked in that direction with optical telescopes, we saw almost nothing of significance. The culprit was our own galaxy. The Great Attractor lies directly behind the dense plain of the Milky Way, in a region astronomers poetically term the zone of avoidance. Here, thick clouds of interstellar gas and dust block our view, like trying to see a distant mountain range through a dense, dusty fog. The true nature of this hidden gravitational monster remained shrouded. The breakthrough came when we started to listen instead of just look. Radio, infrared, and X-ray telescopes can peer through that galactic fog. What they revealed was not a single monstrous object, but an immense concentration of mass, a colossal gathering of galaxies known as the Norma cluster. This cluster, with thousands of galaxies bound together by gravity, forms the dense central core of the Great Attractor region, but the story grew even bigger. In 2014, a team of astronomers mapping the motions of galaxies made a staggering discovery. They realized that the Great Attractor is not the final destination, but merely a waypoint. It is the gravitational heart of something far more immense, a cosmic continent they named the Laniakea supercluster. Laniakea, a Hawaiian word meaning immense heaven, is our true home. It is a vast filamentary web containing over 100,000 galaxies, including our own Milky Way, all flowing along invisible rivers of gravity toward the same great basin. So the pull we feel is the collective gravity of this entire supercluster, with the Norma cluster as its most massive hub. Yet the quest is not over. The precise distribution of all the mass, including the elusive dark matter that must be holding this structure together, is still being mapped. The Great Attractor taught us a humbling lesson that sometimes the most powerful forces in the universe are hidden behind the very walls of our own celestial home, waiting to be discovered not by looking at the light but by feeling the pull. The Great Attractor reveals our place in a vast supercluster, but some structures in the cosmos stand alone in their perfect, inexplicable symmetry. Gaze upon Hoag's object, a galaxy that looks less like a natural formation and more like a cosmic bullseye fired into the void. Discovered by astronomer Arthur Hoag in 1950, this stunning celestial object presents a puzzle that has endured for decades. At its heart lies a nearly perfect sphere of ancient yellow stars. Surrounding this core is a brilliant, pristine ring of vibrant blue stars actively forming new suns, and between them, a dark, seemingly empty gap of profound nothingness stretches like a moat around a stellar castle. The separation is so clean, so absolute, it appears almost artificial. How does such a thing form? The most compelling theory points to a violent past, a galactic collision from billions of years ago. The idea is that a smaller galaxy might have plunged straight through the heart of a larger disk galaxy. Like a stone dropped into a pond, this immense gravitational disturbance would have sent ripples of gas and dust racing outward, compressing material into a wave that triggered a frenzy of star formation in a perfect ring, while leaving the central core relatively undisturbed. Yet there are problems with this story. Hoag's object is remarkably isolated, with no obvious culprit galaxy nearby to have caused such a collision. This leads to an alternative idea that it formed from an unstable disk that spontaneously rearranged itself, its stars and gas migrating inward and outward to create this stark division. But the physics of such a peaceful transformation remain murky. Its sheer rarity adds to the enigma, a single, perfect ring floating in a sea of more common spiral and elliptical galaxies. And then the mystery deepens with a twist worthy of a cosmic nesting doll. When the Hubble Space Telescope peered into the dark gap of Hoag's object, it captured something astonishing. Nestled within that apparent emptiness, far in the distance behind the ring, is another, much smaller ring galaxy. It is a chance alignment, a glimpse of another universe of structure trillions of kilometers beyond. But for a moment, it creates the illusion of a galaxy within a galaxy, a secret hidden in the void. Hoag's object challenges our assumptions about galactic evolution, proving that sometimes the universe creates forms of such pristine geometry they seem to defy the chaotic forces that shape them. Hoag's object is a masterpiece of galactic geometry, but the universe also carves out emptiness on a scale that defies comprehension. In the constellation of Boötes, the herdsman, astronomers have mapped a region of space so profoundly empty it has earned a chilling nickname, the Great Nothing. This is the Boötes Void, a spherical chasm in the cosmic web measuring an almost inconceivable 330 million light-years across. To grasp that scale, if you placed our Milky Way galaxy at its center, the nearest edge of this void would be over 165 million light-years away in every direction. In a universe where galaxies cluster into great walls and filaments like glitter on a vast spiderweb, this void is a gaping hole. Based on the average density of galaxies, a region this size should contain at least 10,000 galaxies. Instead, surveys have found only about 60, scattered like lonely islands in an ocean of absolute darkness. The existence of such a colossal underdensity poses a serious challenge to our models of cosmic structure. The prevailing theory of the Big Bang and the influence of dark matter predicts that matter should be distributed in a relatively even, frothy pattern, not with gaps this enormous. It is as if you baked a giant loaf of raisin bread and found a spherical region the size of your fist that contained only 2 or 3 raisins. How could this happen? One leading theory suggests it is not a single void, but the result of several smaller voids merging together over billions of years, their combined emptiness creating a supervoid. Another, more speculative idea is that the Boötes Void might be the imprint of an encounter with a parallel universe in the multiverse, a cosmic bruise from a collision with another reality. The few galaxies that do cling to existence within this great desert are fascinating in their own right. They are isolated, evolving in profound solitude, cut off from the frequent galactic interactions that shape most others. Studying them is like studying life in the deepest trenches of the ocean, organisms adapted to an environment of extreme scarcity. The Boötes Void is a monument to absence, a sobering reminder that the fabric of our universe is not just studded with light, but also stitched with pockets of nothingness so vast they challenge our very understanding of everything. While the Boötes Void is a staggering emptiness, our radio telescopes have recently begun to paint the sky with mysterious structures of immense, ghostly light. They are called odd radio circles, or ORCS, and they are exactly that, odd. Discovered just a few years ago in the 2020s by astronomers using the revolutionary Australian Square Kilometre Array Pathfinder, these are enormous, faint rings that appear only in radio wavelength. When you look at the same patch of sky with an optical telescope, you see nothing. Switch to X-ray or infrared, and again the circles vanish. They exist only as whispers in the radiostatic, colossal halos that could each comfortably contain an entire galaxy within their bounds. Their scale is almost incomprehensible, each one spanning about 1 million light-years across. To put that in perspective, if you placed our Milky Way at the center of one of these circles, its outer edge would stretch far beyond our nearest galactic neighbors. The sheer size is the first major clue pointing to an event of unimaginable power. One leading theory suggests these are the aftermath of a gargantuan explosion, perhaps the merger of two supermassive black holes. Such a cataclysm would send a spherical shockwave of energy screaming through intergalactic space for hundreds of millions of years, and we might be seeing the radio glow from that ancient, expanding bubble as it brushes against thin gas between galaxies. Another idea proposes they are the imprint of a galactic wind, a titanic outflow of material driven by a frenzy of star formation within a central galaxy, blowing a perfect bubble into the cosmic medium. But the most exotic possibility, one that stretches the limits of known physics, is that we are looking at the projected throat of a space-time wormhole. In theory, the intense gravitational forces at a wormhole's mouth could accelerate particles to create a ring of radio emission. While this remains a highly speculative long shot, it underscores just how utterly novel these objects are. The ORCS represents something rare and thrilling in modern astronomy, a completely new class of celestial object, identified not in the distant past but within our current decade. They remind us that our maps of the cosmos are still unfinished, and that the universe continues to reveal its secrets in forms we have only just begun to imagine. The universe can build ghostly rings of radio light, and it can also forge cosmic relics frozen in time. In the constellation Perseus, a galaxy named NGC 1277 drifts in apparent silence, a massive, smooth, reddish disk. To the untrained eye, it seems unremarkable, just another blur among millions. But to astronomers, this galaxy is a living fossil, a pristine snapshot of the universe as it was over 10 billion years ago. NGC 1277 is classified as a lenticular galaxy, a hybrid shape somewhere between a spiral and an elliptical, but its true nature is far stranger. It is a relic galaxy composed almost entirely of ancient red stars. There are no vibrant blue clusters of newborn suns, no swirling arms of dust and gas where stars are born. This galaxy's star formation shut down completely and abruptly, roughly 12 billion years in the past. It is a cosmic museum piece that stopped evolving when the universe itself was in its wild adolescence. The mystery of why it stopped is tied to a discovery about what lies at its heart. When astronomers measured the motions of stars swirling around its core, they calculated the mass of the central black hole. The result was staggering. This supermassive black hole is not just large, it is impossibly, disproportionately huge. It makes up a staggering 14% of the galaxy's entire central bulge mass. To understand how bizarre this is, consider our own Milky Way. Our central black hole, Sagittarius A star, is a behemoth 4 million times the mass of our Sun. Yet it accounts for less than 1% of our galactic bulge's mass. In most galaxies, the black hole and the bulge grow together in a balanced partnership. NGC 1277 shatters that rule. Its black hole is a king that utterly dwarfs its kingdom. How did such a monstrous object form in what is now a dormant galaxy? The leading theory paints a picture of cosmic gluttony on an epic scale. Billions of years ago, in the dense, crowded early universe, this galaxy was likely a voracious cannibal. It may have gorged itself on a feast of smaller galaxies and vast rivers of gas during a brief, hyper-violent period of growth. This furious consumption would have fed both a rapid burst of star formation and the insane growth of the central black hole. Then something catastrophic happened. Perhaps it consumed all the available fuel in its immediate vicinity. Maybe the black hole itself, after its feast, unleashed such energetic blasts that it blew away the remaining gas needed to make new stars. The galaxy's engine simply ran out of fuel and shut down. Since that epochal moment, it has drifted through time unchanged, its giant black hole now a sleeping giant surrounded by the aging stars of its ancient feast. NGC 1277 challenges a fundamental assumption that galaxies and their black holes evolve in lockstep. Here, we see a black hole that grew too fast, too greedily, and in doing so, may have doomed its own galaxy to an eternal, quiet retirement. It is a preserved moment of cosmic excess, a warning from the early universe about what can happen when a galaxy consumes everything in its path. A sleeping black hole is the heart of a galaxy, but what happens when that heart is violently torn from its chest and sent screaming into the void? The Hubble Space Telescope has found exactly that, a supermassive black hole with the mass of 20 million suns, not sitting quietly at a galactic center but in full flight. It is a cosmic runaway, blasting through the darkness at such a speed it could travel the distance from Earth to the Moon in just 14 minutes. And in its wake, it is not leaving destruction but creation. Trailing behind this gravitational monster is a breathtaking corridor of newborn stars, a brilliant streak of blue light stretching an almost unbelievable 200,000 light-years long, twice the diameter of our entire Milky Way. This is not a trail of debris but a stellar nursery forged in chaos. The physics behind this spectacle is as elegant as it is violent. As the black hole plows forward at supersonic speeds, it slams into the tenuous clouds of gas that float in intergalactic space. Imagine the bow wave in front of a speedboat, but on a cosmic scale. The black hole's immense gravity and its incredible motion create a powerful shockwave that compresses the gas ahead of it. This compression is so sudden, so intense, that it triggers the collapse of that gas into dense knots, igniting the fires of nuclear fusion and lighting up new suns in a straight line behind the speeding object. The black hole itself is not actively feeding, it is not a quasar. It is a dark bullet, and the star-forming trail is the glowing wound it leaves in the fabric of space. But how does a supermassive black hole, an object with the gravitational pull to anchor an entire galaxy, get kicked out in the first place? The answer lies in a rare and spectacular game of intergalactic billiards. Astronomers believe this saga began with a close encounter or even a collision between two galaxies. Each galaxy brought its own supermassive black hole to the merger. As the galaxies spiraled together, their central black holes would have begun a gravitational dance, orbiting each other ever closer. Then, a third galaxy may have joined this chaotic waltz, introducing a third black hole into the mix. In this unstable three-body interaction, the complex push and pull of gravity can act like a cosmic slingshot. One of the black holes can be flung away at tremendous speed, ejected from the newly forming galactic core entirely. That is the likely origin story of this runaway behemoth. We are witnessing the aftermath of a gravitational catastrophe, a shot fired across the cosmos where the projectile is an invisible singularity and the trace around is a river of newborn stars. It forces us to reconsider the nature of these cosmic anchors, revealing they are not always stationary lords of their domain, but can sometimes become marauding engines of creation, painting the darkness with starlight as they flee the scene of a galactic crime. That runaway black hole carves new stars from chaos, but the earliest stars in the cosmos faced a far quieter and more profound problem. How do you build a sun from almost nothing? In the faint halo of our own Milky Way, astronomers have found a star that is a living fossil from that primordial era, a relic so pristine it defies the very rules we wrote for star birth. Its catalog number is a mouthful, SDSSJ102915+172927, but its story is simple and revolutionary. This ancient star is composed almost entirely of hydrogen and helium, the raw materials forged in the Big Bang. It contains less than 1/20,000,000th the amount of heavier elements, what astronomers call metals, found in our Sun. According to our long-standing theories of star formation, this star should be impossible. Here is the puzzle. In the early universe, clouds of pure hydrogen and helium gas are incredibly inefficient at cooling down. For a gas cloud to collapse under its own gravity and ignite a star, it must be able to shed heat to shrink and condense. Heavier elements, even in tiny amounts, act like a cosmic radiator coolant. They help the cloud radiate away its heat, allowing it to fragment and collapse into dense knots that become stars. A cloud of only hydrogen and helium, the theory stated, would stay too hot and puffy. It would either never collapse, or it would have to be so monstrously huge that it could only form a single gargantuan star hundreds of times the mass of our Sun. Yet here is SDSSJ 102915, a small, ancient star with a mass less than our Sun, made of almost nothing. It somehow formed from a cloud that, by all rights, should have remained a wisp of hot gas forever. Its very existence is a direct challenge to our textbooks. How did it cool down? One speculative idea points to dark matter. In the dense early universe, dark matter particles may have collided and annihilated within these first gas clouds, providing an exotic and powerful new way to shed energy and trigger collapse. Another possibility is that the hydrogen molecules themselves, in the absence of any contaminants, found a different, slower path to cooling that we have not fully accounted for. This star is not just an oddity, it is a messenger. It tells us that the first generation of stars, the ones that lit up the cosmic dark ages, may have been far more diverse than we ever imagined. They were not all behemoths that lived fast and died young in spectacular supernova. Some were quiet, small, and frugal, forming against all odds from the barest ingredients the universe had to offer. This impossible star forces a humbling rewrite of the first chapter of stellar evolution, proving that the cosmos found a way to build lights in the darkness long before it had the proper tools. From the quiet frugality of the first stars, we turn to a galaxy that seems to have misplaced the very scaffolding of the cosmos. It is called NGC 1052DF2, and it is a ghost. This ultra-diffuse galaxy is so wispy you can literally see right through it to the galaxies beyond. A faint smudge of starlight with almost no central bulge, no spiral arms, and most shockingly, almost no dark matter. This last point is what makes it a cosmic heretic. For decades, the existence of dark matter has been the cornerstone of modern cosmology, the invisible glue that explains why galaxies spin as fast as they do without flying apart. It is the hidden skeleton upon which the visible universe is built. Yet DF2 appears to have no skeleton at all. The evidence came from studying its glittering jewels, 10 bright globular clusters that orbit the galaxy's outskirts. By measuring the speed of these clusters, astronomers can calculate the total mass of the galaxy pulling on them. The faster they move, the more mass, both seen and unseen, must be present to hold them in orbit. The results were unequivocal and baffling. The clusters were moving slowly, so slowly that the total mass needed to explain their motion was almost exactly equal to the mass of the visible stars themselves. There was no room left for the vast halo of dark matter that should be there, outweighing the stars by a factor of 10 to 1. It was like watching a child effortlessly spin a heavy hammer above their head, only to realize the hammer's head is made of painted foam. The weight you expected simply isn't there. The immediate, thrilling question was obvious. Could this galaxy disprove dark matter entirely? Perhaps an alternative theory of gravity, like modified Newtonian dynamics, or MOND, which tweaks the laws of physics to explain galactic rotation without invisible matter, was correct after all. But the story quickly grew more complex. A violent past offers a more likely, though still extraordinary, explanation. DF2 lies near a massive elliptical galaxy called NGC 1052. Astronomers theorize that billions of years ago, DF2 could have been a more typical, dark matter-rich dwarf galaxy that ventured too close to its gigantic neighbor. In a process called tidal stripping, the immense gravitational tides from the larger galaxy could have violently torn away both its dark matter halo and much of its gas, leaving behind the bare, diffuse skeleton of stars we see today. The visible stars, being more concentrated in the galaxy's center, would have held on tighter and survived the ordeal. This scenario turns DF2 from a refutation of dark matter into a tragic relic of cosmic violence, a galaxy that had its hidden essence ripped away. Yet even this explanation challenges our models. Simulations show it is incredibly difficult to strip away all of a galaxy's dark matter without also completely destroying the galaxy itself. The very existence of DF2, a coherent galaxy seemingly born without or stripped of its dark matter, forces astrophysicists to re-examine the fundamental relationship between dark matter and the stars it supposedly shepherds. It proves that dark matter is not an inseparable part of a galaxy. It can be lost, creating cosmic phantoms that drift through space, challenging us to understand the rules of a universe where the most fundamental ingredient can sometimes simply go missing. A galaxy stripped of dark matter is a phantom, but some particles are phantoms from the very moment of their birth. Deep beneath the ice of the South Pole, a cubic kilometer of pristine Antarctic glacier has been transformed into the universe's most unusual telescope. Its name is Ice Cube, and it is not looking for light, it is waiting for ghosts. On September 22, 2017, it caught one. A single, impossibly energetic neutrino, a particle so elusive it is nicknamed the ghost particle, slammed into the atomic nucleus of an oxygen atom within the ice. The collision produced a faint blue flash of light called Cherenkov radiation, which Ice Cube's thousands of embedded sensors detected. This was not unusual in itself. Ice Cube sees neutrinos all the time. But this particular ghost carried a passport. From the pattern of light, scientists could trace its incoming direction back to a tiny patch of sky. They sent an urgent alert to observatories around the world and in space, telling them to look there. What they found 4 billion light-years away was a monster waking up. It was a blazar, a galaxy centered on a supermassive black hole that is actively feeding. Unlike normal black holes, this one was not quiet. It was firing a relativistic jet of radiation and particles directly at Earth, a cosmic blowtorch of unimaginable power. At that very moment, the Fermi Gamma Ray Space Telescope and other instruments saw this blazar, named TXS0506+056, in a state of violent eruption, its gamma-ray output flaring dramatically. The pieces of the puzzle snapped together with breathtaking clarity. That single, high-energy neutrino was a bullet fired from that distant blazar's jet. For the first time in history, we had pinpointed a concrete source of these cosmic neutrinos. This event, catalogued as Ice Cube 170922A, marked the dawn of a revolutionary new era, multi-messenger astronomy. Think of it like this: before this, studying the cosmos was like watching a silent movie. We could see the explosions and the drama, but we heard nothing. With neutrinos and their partner messengers like gravitational waves, we have now turned on the sound. Each type of messenger carries different information. Light shows us the hot, energetic surfaces. Gamma rays reveal the most violent processes. Neutrinos, however, come straight from the engine room. They are born in the heart of cosmic accelerators, in the chaotic maelstrom around black holes and in the shocks of exploding stars. And because they are ghosts, they travel for billions of years without being deflected by magnetic fields or absorbed by dust. They fly in a perfectly straight line from their source, delivering a pristine message about the conditions of their birth. The bizarre nature of the neutrino itself is what makes this possible. These are the most abundant particles with mass in the universe, yet they are famously aloof. Trillions pass through your body every second, interacting with virtually nothing. They have no electric charge and only interact via the weak nuclear force, meaning they can sail through entire planets as if they were empty space. To catch just one requires a detector of absurd scale, like Ice Cube's gigantic volume of ice, or waiting for the incredibly rare direct collision. That is why that one detection was so precious. It was a direct tracer bullet from a cosmic particle accelerator 4 billion light-years away, telling us unequivocally that the violent jets of supermassive black holes are powerful enough to accelerate particles to energies far beyond anything we can create on Earth. This single ghost particle did more than solve an old mystery. It opened a new window on the most violent machinery in the universe, allowing us to listen to the whispers of engines hidden behind curtains of dust and time. That ghost particle came from an engine of unimaginable fury, yet the universe forges treasures in the most hellish of places. Orbiting a sun-like star 40 light-years away is a world of pure extravagance, a planet that turns our understanding of geology into science fiction. It is 55 Cancri E, a super-Earth with a secret. This world is thought to be composed largely of carbon, the same element in the graphite of your pencil and the coal in the ground. But here, under pressures millions of times greater than Earth's atmosphere and scorching temperatures, that carbon has likely crystallized into something astonishing, a vast planetary interior of diamond. Imagine not a few sparkling gems, but a geological layer hundreds or thousands of kilometers thick, a bedrock of crystallized carbon. This diamond planet's composition is a direct reflection of its star, which is unusually rich in carbon compared to our own silicate-rich sun. From that carbon-heavy stellar nursery, the planet formed with a chemistry utterly alien to our own rocky, oxygen-dominated Earth. The conditions on its surface are as brutal as its interior is dazzling. 55 Cancri E orbits so close to its star that a full year, one complete trip around, takes only about 18 hours. This intimate dance locks the planet in a gravitational embrace that has likely forced one hemisphere to permanently face the star, creating a world of eternal day and eternal night. The day side is a vision of hell, with surface temperatures soaring above 2,500 degrees Celsius, hot enough to melt granite and vaporize most metals. Observations suggest this scorching face may not even be solid, but a global ocean of bubbling, incandescent lava, constantly churned by stellar heat and gravitational tides. The night side, while slightly cooler, is still unimaginably hot by our standards. This creates a planet of staggering extremes, a diamond core wrapped in a mantle of graphite, possibly topped by a boiling lava sea, all under a sky dominated by a blindingly close sun. The existence of 55 Cancri E showcases the breathtaking diversity of planetary systems. Our solar system, with its silicate and iron-rich worlds, is just one possible outcome. Given a star with a different chemical recipe, you can forge planets of diamond, of solid iron, or of substances we have yet to name. This world is a testament to cosmic alchemy, proving that the universe can create realms of unimaginable wealth in environments of equally unimaginable violence. A diamond world showcases cosmic extremes, but some stars endure a fate even more bizarre than total annihilation. They become zombies. In the standard cosmic playbook, when a white dwarf star, the dense Earth-sized corpse of a sun-like star, steals too much matter from a companion, it crosses a critical threshold. This triggers a runaway thermonuclear explosion so violent it obliterates the entire white dwarf in a flash, a brilliant event known as a Type I supernova. Nothing is left behind except an expanding cloud of stellar debris. This model is a cosmic standard candle, a predictable explosion used to measure the vast distances of the universe. But in 2012, astronomers witnessed a supernova that broke the script. Designated SN 2012Z, it was a peculiar, weaker blast. When they looked at archival Hubble Space Telescope images of its host galaxy taken years before the explosion, they saw something impossible. The progenitor star was still there. It had survived. This event belongs to a rare class called a Type IX supernova, a partial explosion. Here is how the zombie star is born. A white dwarf and a helium-rich companion star are locked in a tight orbit. The white dwarf's fierce gravity steadily pulls material, primarily helium, from its partner. this stolen fuel accumulates on the white dwarf's surface. Normally, this leads to the total destruction of the dwarf, but in the IAC scenario, the helium on the surface may ignite first in a violent detonation. This surface blast is like setting off a bomb on the star's skin. It blows the white dwarf's outer layers into space in a powerful but not terminal explosion. The shockwave from this surface detonation then travels inward, potentially triggering a second, incomplete fusion reaction in the star's carbon-oxygen core. The result is not a complete disintegration but a severe stellar injury. The explosion ejects a significant portion of the star's mass but leaves the dense core battered, bruised, and very much intact. This leftover remnant, a scarred and shrunken white dwarf, is the zombie. It is a star that went through a supernova and lived to tell the tale. This challenges the fundamental idea that Type Ia supernova are always total, one-off events. Instead, the IAX class suggests a new path, a supernova that can fail. The zombie star, now stripped of some mass and possibly reignited by the explosion's heat, may even begin the cycle again. It could continue orbiting its now damaged companion, slowly siphoning more material, potentially setting the stage for another partial explosion in the distant future. This discovery forces astronomers to reconsider the final moments of stellar binaries. The cosmos, it seems, has more than one way to light a stellar bomb, and sometimes the fuse only burns halfway, leaving a ghost of a star to wander on. That zombie star endured a partial explosion, but at the heart of a distant galaxy, nature has built a laser of truly cosmic proportions. In the constellation Ophiuchus, a galaxy known as IRAS 163990937 houses something extraordinary, a megamaser. The name itself tells the story, mega for its immense scale, and maser for microwave amplification by stimulated emission of radiation. It is the cosmic, natural equivalent of a laser, but instead of producing a focused beam of visible light, it emits an intense, coherent beam of microwave radiation. The engine for this phenomenon is a supermassive black hole, but the lasing medium is something wonderfully familiar: water. Vast clouds of water vapor, possibly containing trillions of times more water than all of Earth's oceans combined, swirl in the tumultuous region around the galactic core. These molecules are not passive. They are energized by the fierce radiation from the black hole's accretion disk and the crush of surrounding gas. When a microwave photon of the right frequency passes through this excited cloud, it can trigger the water molecules to release their stored energy in perfect sync, emitting another photon identical in direction, phase, and frequency. This is stimulated emission, the same principle behind human-made lasers, but on a galactic scale. The result is not a visible beam you could see, but an intense, narrowband scream of microwave radio waves that outshines the entire rest of the galaxy at those frequencies. The power is staggering. This single natural maser can outshine our sun by orders of magnitude. For astronomers, a megamaser is not just a curiosity, it is a precision tool. Because the microwave emission is so coherent and comes from such a small, well-defined region, it acts like a brilliant beacon shining from the very heart of the galactic storm. By mapping the subtle shifts in the frequency of this maser light using radio telescopes, scientists can measure the motion and distribution of gas swirling around the black hole with incredible accuracy. It lets them weigh the central black hole, chart the speed of its accretion disk, and probe the complex dynamics of a region otherwise obscured by dust. This turns a bizarre natural amplifier into a key for unlocking the secrets of galactic nuclei. While it evokes images of science fiction superweapons, the galactic megamaser is a testament to the universe's ability to orchestrate perfect order from chaos, using simple water molecules and the fury of a black hole to broadcast a signal that helps us map the darkness. The universe's megamasers broadcast with perfect coherence, but some stellar deaths are masterpieces of cosmic confusion. In September 2014, the Intermediate Palomar Transient Factory telescope caught what seemed like a routine supernova in a distant galaxy. Designated IPTF-14 HLS, it brightened, peaked, and began to fade as expected. Then it did the impossible. Instead of continuing to dim into obscurity, the star's light curve plateaued, and then, months later, it grew brighter again. It brightened and faded not once, but at least 5 distinct times over the course of 600 days, as if the star was exploding in slow motion, taking multiple deep breaths of cataclysmic energy. This was not a temporary pause, it was a sustained defiance of physics. A normal core collapse supernova, where a massive star runs out of fuel and its core collapses into a neutron star or black hole, is a single, violent event. The star's outer layers are blasted outward in one tremendous shockwave, creating a brilliant flash that lasts for months before fading. IPTF-14 HLS shattered that model. Over its bizarre 2-year performance, it released a total amount of energy equivalent to a normal supernova, but it did so in staggered, repeated installments. Even more baffling was the story told by its spectrum, the fingerprint of its chemical composition. The light revealed it was an incredibly massive star, perhaps 50 to 100 times the mass of our Sun. A star that colossal should have died once completely in a pair instability supernova that leaves no remnant behind, yet here it was, apparently surviving multiple blasts. How could a star explode more than once? The leading theory to explain this cosmic encore is as extreme as the event itself, a pulsational pair instability supernova. In a star of immense mass, the core can become so hot that light itself begins to transform. Photons of gamma-ray radiation spontaneously convert into pairs of electrons and their antimatter counterparts, positrons. This process robs the core of the internal pressure that was holding the star up against its own gravity. The core partially collapses, triggering a violent thermonuclear explosion that blows off the star's outer layers. But crucially, this explosion is not quite powerful enough to destroy the entire star. The remaining core, now stripped of some mass, stabilizes. It continues burning for a while until the pair production instability threshold is crossed again, leading to another partial explosion. This cycle could repeat several times over decades or centuries, with each pulsation ejecting another shell of material. When the final, terminal collapse happens, the resulting shockwave plows through all these previously ejected shells, lighting them up in sequence and creating the observed series of brightening and fading we witnessed. An alternative, equally wild idea involves the birth of a magnetar, a neutron star with a magnetic field quadrillions of times stronger than Earth. In this scenario, the initial collapse forms this immensely powerful magnetar. Its furious magnetic field acts like a cosmic brake, dumping enormous energy into the expanding debris over a prolonged period, reheating it and causing the repeated brightenings. IPTF-14 HLS stands as a monumental puzzle, a stellar death that refused to follow the script, forcing astronomers to rewrite the book on how the most massive stars in the universe meet their end. That star's explosive encore was a spectacle of light, but some worlds are born into eternal silence. Drifting alone through the blackness between stars, far from the warmth of any sun, is a lonely wanderer known as CFBDS IR214904003. This is a rogue planet, a world untethered from any solar system, condemned to an endless journey through interstellar space. It was discovered not by the wobble of a star or the dimming of a distant sun, but by its own faint, mournful glow in the infrared spectrum. This object, with a mass estimated at 4 to 7 times that of Jupiter, is still warm from the heat of its violent birth, radiating a weak thermal signature that our telescopes could just barely pick up against the cold backdrop of the void. Its origins are a cosmic mystery with 2 compelling and tragic possibilities. The first is a story of exile. In the chaotic early days of a young solar system, gravitational interactions between giant planets can be brutal. A close encounter with a sibling world could have acted like a gravitational slingshot, hurling this planet out of its birthplace at tremendous speed, casting it adrift forever. The second possibility is even more profound, that it formed in isolation like a failed star. In a dense cloud of gas and dust, a small knot may have collapsed under its own gravity, but without accumulating enough mass to ignite the nuclear fusion that defines a star. It became a planetary mass object born alone, a cosmic orphan from the very beginning. Imagine the landscape of such a world. There is no sunrise, no day, no year. The sky is a perpetual, star-studded black, with no central sun to outshine the distant galaxies. The surface, if it has a solid surface, would be frozen beyond comprehension, bathed only in the feeble glow of internal heat and the cold light of the Milky Way. Any atmosphere would likely have collapsed into strange, frozen layers. Yet, within that deep freeze, there might be a sliver of hope for warmth. The constant gravitational squeezing from its own mass, or the decay of radioactive elements in its core, could maintain a subsurface ocean of liquid water, locked under a shell of ice dozens of kilometers thick. This rogue planet is a ghost of the galaxy, a reminder that for every world bathed in starlight, there may be countless more drifting unseen in the darkness, their stories untold and their skies forever starless. Even a rogue planet's frozen journey is not the strangest shape the cosmos can sculpt. From the darkness emerges a structure so eerily familiar it seems to defy chance, a colossal skeletal hand reaching across 150 light-years of space. This is MSH 1552, captured in stunning detail by the Chandra X-ray Observatory. In this image, the universe appears to have left its fingerprint. The glowing nebula, with its long, slender fingers and extended wrist, bears an uncanny, almost haunting resemblance to a human hand. But this is no phantom. It is a spectacular example of violent astrophysics and beautiful coincidence. The power behind this cosmic gesture is a tiny, city-sized cinder at its heart, a young and ferociously energetic pulsar known as PSRB 150958. This neutron star, the remnant of a supernova that exploded roughly 1,700 years ago, is spinning nearly 7 times every second, whipping its magnetic field around at a significant fraction of the speed of light. That furious motion transforms the pulsar into a dynamo, generating a hurricane of high-energy electrons and positrons that stream outward into space. This torrent is the pulsar wind, and it is blowing a vast, invisible bubble into the surrounding cloud of gas and dust left over from the star's death. The result is what we see as the hand. The most energetic particles from the pulsar collide with magnetic fields in this debris, causing them to spiral and emit the brilliant X-ray glow that Chandra sees. The finger-like structures are not solid, but are actually tendrils of energized material, shock waves where the pulsar wind slams into denser knots of gas in the surrounding cloud. These knots act like obstacles in a river, shaping the flow of energy into elongated, twisted forms. The wrist is a jet of material being shot out from the pulsar's poles. It is a perfect demonstration of how chaos and physics can conspire to create an illusion of familiarity. We see a hand because our brains are wired to find patterns, especially human ones, in random shapes. Yet the science behind it is what truly captivates. This image is a real-time snapshot of energy transfer on a cosmic scale. It shows how the raw, destructive power of a stellar corpse can be channeled into sculpting the interstellar medium, lighting up the debris of its own death into breathtaking forms that endure for millennia. The cosmic hand is both a marvel of pareidolia and a textbook example of a pulsar wind nebula, a reminder that the universe is an artist that works with the tools of magnetism, shockwaves, and sheer raw power. The universe sculpts hands from starlight and hurls planets into the dark, but its grandest motions may be hidden in the subtlest of whispers. there is a river flowing through the cosmos and we are caught in its current. This is the dark flow, a controversial and deeply puzzling observation that suggests a vast, coherent drift of galaxy clusters toward a single point on the edge of everything we can see. It is not the expansion of space itself, but a distinct directional motion superimposed upon it, like a slow, universal tide pulling everything in one specific direction. The evidence comes from studying the hot gas that permeates massive clusters of galaxies. As the cosmic microwave background radiation, the ancient afterglow of the Big Bang, passes through this searing gas, the gas's electrons give the photons a slight energy boost. This is called the kinetic Sunyaev-Zeldovich effect, and it leaves a tiny, measurable imprint in the microwave background. By analyzing this imprint across hundreds of clusters, astronomers can detect the cluster's bulk motion through space. What they found was startling. These colossal structures, separated by hundreds of millions of light years, appear to be streaming together at speeds of several hundred kilometers per second toward the same patch of sky, a direction roughly toward the constellations Centaurus and Hydra. This motion is too large and too coordinated to be explained by the gravitational pull of any known structure within our observable universe. The Great Attractor and the Laniakea supercluster are powerful, but their influence is local. The dark flow suggests a pull from something far beyond our cosmic horizon, from a region of space whose light has not had time to reach us since the beginning of the universe. The implications are as profound as they are unsettling. One possibility is the gravitational tug of a truly gargantuan mass, a structure so immense it lies outside our observable bubble. This could be a concentration of matter and dark matter on a scale we can scarcely comprehend, a supercluster whose gravity reaches across the void. An even more radical idea suggests the pull originates from a neighboring universe in a vast multiverse. In this scenario, the gravity from a cosmos adjacent to our own could be leaking through the fabric of space-time, creating a directional drift in our own universe. A third, equally mind-bending hypothesis points to a relic from before the Big Bang, an imprint of a prior state of existence that set the universe into a kind of cosmic slide. The very idea challenges a foundational principle of cosmology, the cosmological principle, which states that on the largest scales, the universe is homogeneous and isotropic, meaning it should look the same in all directions with no preferred center or direction. The dark flow, if real, hints at a universe that is not perfectly uniform, that may have a grand architecture extending beyond what we can see. The debate within the scientific community is intense and ongoing. Some analyses have questioned the statistical significance of the original findings, suggesting the flow might be an artifact of incomplete data or measurement uncertainties. Others have found supporting evidence in different datasets. The mystery remains unresolved, a tantalizing thread at the very limit of our observations. It forces us to confront a humbling possibility that the greatest forces shaping our cosmic journey may be invisible not because they are dark, but because they lie forever over the horizon. That dark flow hints at a universe of hidden structure, but some of its most profound clues are written in a language of heat and light we are only beginning to translate. Scattered across the galaxy, from the glowing shells of dying stars to the cold clouds between them, our infrared telescopes detect a set of mysterious fingerprints. They are called the Unidentified Infrared Emission Features, or UIES, and for decades they have been a quiet, persistent puzzle in the data. These are not sharp lines, but broad, rounded humps in the infrared spectrum, specific wavelengths where these cosmic objects glow a little brighter than they should. Think of it like trying to identify a material by the heat it radiates, only to find its thermal signature has a strange, blurry shape you cannot match to any known element. The most famous of these are the unidentified infrared bands, a family of these features that appear together again and again in wildly different environments. They show up in the turbulent debris of planetary nebulae, in the diffuse gas of the interstellar medium, and even in the light of other galaxies. Wherever there is carbon and energy, these bands seem to appear. For a long time, their source was a complete mystery. What could possibly produce such a common, yet unidentified, set of signals? The leading suspect today is not a simple atom, but an incredibly complex molecule. The evidence strongly points to a class of compounds called polycyclic aromatic hydrocarbons, or PAHs. These are large, stable molecules made of interconnected rings of carbon and hydrogen atoms, essentially the sooty flakes you might find in a candle flame or on a charred piece of toast. Their structure is perfect for emitting in the infrared at the exact wavelengths we see in those mysterious bands. The idea that the galaxy is filled with these complex organic compounds is staggering. It means that the fundamental chemical building blocks for life, or at least for the carbon-based chemistry that leads to life, are not confined to planets. They are everywhere, a faint, sooty dust sprinkled across the void. Yet declaring the case closed would be premature. The exact identity of the molecules causing the UIES is still not pinned down. While PAHs are the prime candidates, no single, specific molecule has been definitively matched to all the observed features. It could be a mix of many different related compounds, or even something more exotic like tiny flakes of graphene or fullerenes, soccer ball-shaped carbon cages. The deeper puzzle is how these delicate, complex molecules survive and form in the first place. The environments where we detect them are often brutally harsh, flooded with destructive ultraviolet radiation from nearby hot stars. It is like finding intricate paper sculptures holding their shape in the middle of a hurricane. One theory suggests they form right in the violent outflows of dying stars, where carbon atoms link together in the expanding shells of gas. Another proposes they are built piece by piece on the surfaces of cold dust grains in dark clouds, shielded just enough to allow complex chemistry to occur. The presence of these UIES transforms our view of interstellar space from a barren vacuum into a vast cosmic chemistry lab, one that is pre-processing the ingredients for biology on a galactic scale. Every planetary nebula glowing with these unexplained bands is not just a tomb for a star, but potentially a nursery for the chemistry of future worlds. This mystery connects the death of suns directly to the raw materials for life, written in a faint infrared signature we are still learning to read. These infrared whispers hint at a chemistry spread across the void, but some stars are not content to simply drift within it. They flee, racing through the Milky Way's spiral arms at speeds that defy imagination are the hypervelocity stars, celestial runaways moving so fast they are destined to escape our galaxy's gravitational grasp forever. One of the fastest known is US 708, a small, helium-rich star hurtling through space at over 1,200 kilometers every second. At that velocity, you could travel from the Earth to the Moon in just under 6 minutes. This star is not merely orbiting the galactic center, it is on a one-way trip out into the intergalactic darkness, a refugee from some ancient cosmic catastrophe. The sheer energy required to accelerate a star to such a speed points to only a few possible engines, each a story of stellar violence. The leading theory involves a binary star system meeting a sudden, explosive end. Picture two stars locked in a close dance, one a massive star destined for a supernova, the other a smaller companion like US 708. When the massive star exhausts its fuel, its core collapses and it detonates. In a standard supernova, this explosion is symmetric, and the binary pair might simply be disrupted, sending both stars wandering apart at moderate speeds. But for a hypervelocity star, the explosion must be profoundly lopsided. If the supernova's blast is off-center, like a rocket engine firing from one side of the dying star, the sudden kick can catastrophically disrupt the gravitational bond. The surviving companion is not just released, it is violently punted away, flung across the galaxy like a stone from a sling. inheriting a tremendous fraction of the explosion's asymmetric energy. US 708 fits this story well, its composition and speed aligning with models of a star stripped of its outer layers by a companion before that companion erupted. But there is another, even more dramatic launch pad at the very heart of the Milky Way. Orbiting our galaxy's core is not just stars, but a dense, chaotic swarm of them, all whirling around the supermassive black hole, Sagittarius A star. In this region of extreme gravity, complex gravitational interactions between stars and the black hole can act like a cosmic catapult. A binary star system that ventures too close to the black hole can be torn apart. One star may be captured into a tight orbit, while its partner is whipped around at a ferocious speed and ejected outward, gaining enough velocity to break free from the galaxy entirely. This three-body interaction between the binary pair and the black hole is a perfect gravitational slingshot. The hypervelocity stars born here are messengers from the most extreme environment in our galaxy, their trajectories carrying the invisible fingerprints of the black hole's immense power. As these stellar projectiles streak through the galactic halo, they carve lonely paths where few stars venture. Their journeys raise a profound question about the future of galaxies, as each escape represents a tiny, irreversible leak of mass and light. Over billions of years, countless such ejections could slowly drain a galaxy of its stellar population. Watching a hypervelocity star is like witnessing a prison break on a cosmic scale, a glimpse of the chaotic forces that can overpower the gravitational bonds holding an entire galaxy together. Our galaxy's central black hole may have left a signature far more dramatic than hypervelocity stars. Two colossal, ghostly orbs of gamma-ray light balloon outward from the Milky Way's core, each one a blistering bubble of high-energy radiation stretching 25,000 light-years into space. This is the Fermi bubble structure, a pair of symmetrical lobes that together form an hourglass shape 50,000 light-years tall, dwarfing our entire visible galactic disk. They remained completely hidden until the Fermi Gamma Ray Space Telescope, designed to map the universe's most violent explosions, turned its gaze toward our own galactic center in 2010. What it saw was not a point of light, but a vast diffuse glow, a pair of immense structures that had been invisible to every other type of telescope. Their emission in gamma rays, the most energetic form of light, told a story of immense power. Something millions of years ago must have unleashed a titanic burst of energy from the galactic heart, an eruption so fierce it punched through the dense plane of the Milky Way and inflated these giant bubbles of hot, magnetized gas. The prime suspect sits at the very center of it all, our galaxy's own supermassive black hole, Sagittarius A star. While it is quiet today, the bubbles are evidence of a violent past. The leading theory suggests that several million years ago, Sagittarius A star experienced a period of intense activity. A large cloud of gas, perhaps a wayward star torn apart by tidal forces, fell into the black hole's accretion disk. This sudden feast would have triggered a cataclysm. As matter spiraled inward at near light speed, it grew unimaginably hot, and not all of it crossed the event horizon. Some of the incoming material could have been channeled and focused by powerful magnetic fields into two opposing jets, screaming outward from the black hole's poles at relativistic speeds. These jets, lasting for perhaps tens of thousands of years, would have plowed into the halo of gas surrounding the galaxy, inflating the enormous cavities we see today. The gamma rays we detect are produced by the fast-moving particles within these bubbles slamming into the slower-moving gas and light, a process called inverse Compton scattering. It is the fading afterglow of a monstrous belch from our galactic core, but not all astronomers are convinced the black hole alone is to blame. An alternative theory points to the collective fury of stars. In the densely packed galactic center, periods of intense star formation can create not just new suns, but also countless supernovae. The combined effect of these stellar winds and explosions could, over time, blow a gigantic bipolar superbubble out into the galactic halo. This would be a more gradual, sustained energy output rather than a single explosive event. A third, more exotic idea ventures into the realm of the unseen dark matter. Some models suggest the center of the galaxy could be dense with these mysterious particles. If dark matter particles and their antimatter counterparts were to collide and annihilate there, they could release enormous amounts of energy, potentially in the form of gamma rays, inflating the observed bubbles. While this remains a speculative long shot, it highlights how the Fermi bubbles force us to consider every possible engine for such staggering cosmic structures. They are a permanent scar on our galaxy's face, a testament to an era when the quiet giant at its heart was awake and roaring. The Fermi bubbles are a monument to our galaxy's violent past, but the search for cosmic intelligence often focuses on subtler, stranger absences of light. Among the most perplexing is a young star catalogued as EPIC 204278916. A stellar mystery that echoes the enigma of Tabby's star, but with its own unique and dramatic flair. Located about 400 light-years away, this star is a pre-main sequence M dwarf, still in its cosmic childhood. Observations from the Kepler Space Telescope's K2 mission revealed something astonishing. Over a period of 78 days, the star's light did something unprecedented. It underwent a series of deep, irregular dimming events, with one episode plunging its brightness by a staggering 65%. To lose nearly 2/3 of its light, something truly colossal must have passed in front of it. This was not the gentle, symmetrical dip of a planet. The light curve was jagged, asymmetric, and profoundly deep, suggesting a shape of breathtaking complexity and scale orbiting the young star. The immediate, thrilling question was the same one posed by Tabby's star. Could this be artificial? The notion of a Dyson sphere, a vast swarm of energy-collecting panels built by an advanced civilization, naturally surfaces when faced with such extreme and irregular dimming. The sheer depth of the dimming implies an object or structure with a geometric area far larger than any known planet, one that is also uneven and possibly in many pieces. This star became a prime candidate for projects like Breakthrough Listen, which point radio telescopes at such anomalous stars, listening intently for any hint of engineered signals amidst the cosmic noise. Yet, as with all good mysteries, natural explanations emerge that are nearly as spectacular. The leading theory paints a picture of cosmic adolescence run wild. Because EPIC 204278916 is a young star, it is likely still surrounded by a massive protoplanetary disk of gas and dust, the raw material from which planets form. Within this disk, astronomers propose the existence of a colossal, dusty ring system, perhaps belonging to a newly formed gas giant planet, but this is no simple set of rings like Saturn's. These rings could be tilted, warped, and incredibly extensive, spanning distances larger than the gap between the Sun and Earth. As this ringed planet orbits its star, the complex, spiraling structure of its dusty rings could transit in front of the stellar disk, blocking enormous and irregular amounts of light. An alternative, equally violent idea suggests a swarm of disintegrating comets, not just dozens, but perhaps hundreds of massive, icy bodies breaking apart as they plunge close to the star, creating a vast, opaque cloud of debris. Both scenarios are extreme examples of natural planetary system formation, requiring conditions pushed to their limits. This star perfectly embodies the razor's edge in modern astronomy, the line between investigating natural extreme phenomena and searching for signs of intelligence. It teaches a crucial lesson that the universe is capable of producing awe-inspiring, seemingly artificial patterns through purely physical means. Our duty is to exhaust every natural explanation, to understand the full spectrum of cosmic possibility, because only then does a remaining anomaly become truly profound. The dimming of EPIC 204278916 keeps the dream alive not by proving we are not alone, but by proving the cosmos is stranger than we dared to imagine, capable of building structures so vast they momentarily eclipse their own suns. This search for cosmic intelligence focuses on our own cosmic backyard, but the most profound evidence of our universe's origin is painted across the entire sky. It is the cosmic microwave background, a nearly perfect snapshot of the infant universe, a faint glow from when the cosmos was just 380,000 years old. This map of the Big Bang's afterglow is remarkably uniform, a testament to a smooth and even beginning. Yet, within that smoothness, there is one feature so peculiar it has sparked debate for over a decade, a region of space so cold it defies easy explanation. Astronomers call it the cosmic microwave background cold spot, a vast circular patch in the constellation Eridanus where the temperature of the background radiation is about 70 microkelvins colder than the surrounding average. That may sound minuscule, but on the scale of the entire observable universe, this anomaly is enormous and statistically jarring. If the cosmic microwave background is a nearly perfect thermal blanket, this cold spot is a tear in the fabric, a place where the primordial fire seems to have burned just a little less brightly. The simplest explanation is that it is just a statistical fluke, a 1 in 50 chance occurrence in an otherwise uniform field. The universe is vast and rare things happen. But its size and significance push the boundaries of that simple answer, leading scientists to consider possibilities that sound like they are from the pages of a cosmology textbook's most speculative chapter. One leading theory suggests the cold spot is not a flaw in the ancient light, but a shadow cast by a later structure. It could be the imprint of an immense supervoid, a region of space hundreds of millions of light years across that contains far fewer galaxies and clusters than expected. If such a colossal emptiness exists along our line of sight to the cold spot, the light from the cosmic microwave background passing through it would lose a tiny amount of energy due to a subtle effect called the integrated Sachs-Wolf effect. Think of a photon, a particle of light, falling into the gravitational well of a massive galaxy cluster. It gains energy, becoming slightly hotter or blue-shifted. When it climbs out the other side, it loses that energy again. But in an expanding universe dominated by dark energy, the gravitational landscape itself is changing. A photon falling into a cluster's well and climbing out later, when the well has become shallower due to cosmic expansion, loses a little more energy than it gained. It comes out slightly cooler or redshifted. If that photon passes through a vast region of below-average density, a void, the opposite happens in reverse, resulting in a net cooling. A supervoid large enough could, in theory, create the observed cold spot. The challenge is finding that void. Some surveys have identified a large underdensity in that direction, but its size and emptiness may not be sufficient to fully explain the chilling effect. This leaves the door open for a far more exotic idea, one that reaches beyond our observable universe. The cold spot could be a cosmic bruise, the imprint of a collision with another bubble universe during the epoch of cosmic inflation. In the theory of eternal inflation, our entire cosmos is just one bubble in a frothing multiverse, where new universes constantly nucleate and expand. If, during our universe's own rapid inflationary phase, it brushed against the boundary of a neighboring bubble universe, the interaction could have left a distinct signature in the temperature and polarization of the cosmic microwave background, a circular region of unusual cold. It is a hypothesis that is incredibly difficult to prove, as it relies on physics from beyond our cosmic horizon. But it represents the kind of profound possibility the cold spot forces us to confront. Whether it is a rare statistical fluctuation, the shadow of a titanic emptiness, or a scar from a multiversal encounter, the cold spot remains one of the most significant anomalies in modern cosmology. It is a reminder that the oldest light we can see still holds secrets, and that the map of our beginning may contain directions to realms we have only just begun to dream of. From ghost particles to galactic hands, from diamond planets to stellar zombies, our journey through these 25 cosmic enigmas reveals a universe that is fundamentally, gloriously bizarre. These are not mere curiosities for a dusty textbook, they are the very frontiers of human knowledge, each one a crack in the facade of our understanding. Every strange signal, every impossible structure, every unexplained flow is a direct challenge to the laws we thought we knew, pushing physics to its breaking point and demanding new, more imaginative theories. Astronomy, at its heart, is the study of exceptions, and these events are the most brilliant exceptions of all. They prove that the cosmos is not just vast, but deeply, creatively weird, operating on scales and with a logic that can humble even our boldest imaginations. So the next time you find yourself beneath a clear night sky, remember this: you are not just looking at points of light, you are gazing at a canvas of unresolved mysteries. You are seeing the home of runaway black holes, the nursery of future chemistry, and the graveyard of stars that died twice. That sense of wonder you feel is the first step in a journey of discovery that stretches from your own eyes to the edges of observable reality. The universe is talking in whispers of radio waves and shouts of gamma rays, in the silent geometry of rings and the violent trails of escaping stars. All we have to do is keep listening, keep looking, and stay relentlessly curious. If one of these 25 bizarre events captured your imagination, let us know in the comments below. Which cosmic mystery leaves you the most awestruck, and what do you think it might reveal? For more journeys to the edges of understanding, be sure to like this video and subscribe. The universe still has countless secrets left to share, and we will be here to explore them